Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. After having just recently finished up the knee for the mini milling machine, I'm going to move on to the saddle casting since all my dovetail cutters and blocks and such and desire to cut dovetails is still pretty alert. Anyway, this is what the part looks like when you start. A lot of similar features to the knee. Basically the same type of offset dovetail for a gib, adjustment screws. On the top here, this is a two-piece dovetail. There's another piece that goes on here that will actually push and close so that you can take up the adjustment for the cable itself. Naturally, like anything else, going to start off with a file, create some flat surfaces, blast this thing, and we'll be back and I'll show you what that looks like before we get started. Let's do it. After just a minute in the blaster, the freshly filed surfaces are now true to the world, and they look like the original casting. Now, when I produce this part, when I start machining this part, I'm going to use this as a primary banking area right here, and I'm going to hang it from the back jaw to establish a light cut across the back. That'll give me the opportunity to flip it and establish two parallel surfaces that I can use to grip or trust. Since I'm not going to initially machine this bottom, and it looks like the trough on the casting is true to that bottom, I'm going to use that as my datum to start. May or may not be the right choice, I will find out shortly, but this is ultimately going to be all relieved away for a dovetail cut that will be right here in this corner. But I still need some place to hold it so I can do that, and that's what I'm going to establish. That's the first one. Let's jig it up, hang it, take a couple of cuts over to the mill. By using a variety of parallels spaced at different intervals, I can bank off the surfaces that I've been using all along as datums. Machine surface in the back and the contact surface underneath. I'll be working in the y-axis to do the top dovetail features. And I will move the part over on center. That was just so that you could see the stacking of the parallels. If you pay attention to the black part the black spot that I just put on there, when I bring the dovetail cutter down, you'll see an incredibly small witness mark show up on that area. And it is right there. Now I've set the table to a specific 0, and I'm going to check my gap against this tool with a feeler gauge to make sure everything is good. Now if you're using a feeler gauge to check a carbide tool or a cutter, make sure you make the table shift and then insert the gauge. Do not bring the cutter down onto the gauge or the pin or the block. You will chip the cutter. Lapse time, 12 minutes for that slide. 12 minutes. Take it out, clean it up, reposition it, drill some holes. Be extremely careful when drilling the holes through this surface. If you have parallels underneath, the holes will probably intersect at least one of the parallels. I managed to squeak mine out. I'm going to do the holes before I move this part. I do not usually put an end mill in a drill chuck, but this is a counterbore operation. It's moving about 20 thou worth of material on either side of that hole, and I'm coming straight down with it. There's no side load, so I'm going to say it's okay in this particular situation. I'm going to bring the quill down to a hard stop, and I'm going to bring the table up until I see material start to gather around the bottom of the cutter. That's why I didn't center drill it too large. I wanted to make sure there was area for the cutter to engage. At that time, I will zero out my dial, get the cutter off the deck, and move the table up the depth of the desired counterbore. Comfortably, I would say the next operation are the 3 oblique holes, very much like you saw me do on the knee. Prior to drilling the 3 gib adjustment screw holes, I placed a piece of brass shim stock, the material that they provide for the gib, in the dovetail slot. Using a pin and a drill chuck, I visually aligned the pin to a good contact point on the gib so that it wasn't biased to the top or the bottom. That was then my x-axis 0. Y-axis for the holes was completely visual. The final milled feature on this little part is the top dovetail. Now, I'm not sure who designed this part or why they dimensioned a 3-place decimal to an internal sharp corner, but that's probably not the way to do it. I'm going to lay a pin in there, and I've come up with a stack dimension that I'm going to measure from the back of the part to the outside of the pin, and I can guarantee that with a correctly sized 60-degree tool, that the 125 theoretical sharp corner they're requesting will be there. I'm going to sit this on a block that rests inside the dovetail area right here, so I know that everything is true. It'll be banked up against the jaws this way with a pinch block on the front, and this should be relatively easy and quick to cut. The holes are already in, so I will just simply pick up the holes with a pin, and I'll know exactly where I'm at, and I can come back and put the counterbores and the threads in the part. I'll show you the setup. Very straightforward. Support block underneath resting on a machined surface. The machined surface from the initial operations is pressed against the back stationary jaw. And I'm going to run the dovetail cutter left to right along the x-axis to put that feature in. Let's do it. This feature here was put on in 2 steps. This is a 120 deep roughing cut. And I know exactly where I need to go because of the digital's been set up prior to the cut. You're going to see me insert a pin here in a minute and double check the dimension from the back of the elevation to the back of the part to the pin to establish that impossible 125 corner. Basically, the only way to get to that corner dimensionally would be to put it up on an optical comparator or do it this way. All the redundant steps were edited out for time compression. Okay, moving on. I think I'm going to take a break from the dovetails for a couple of minutes and do the little bracket casting. Now this guy shouldn't pose too much of a problem. But there's a rather aggressive mismatch in the casting right here. And you can see the thickness of this side versus the thickness of that side. Boy, they missed the ball on that one. Not too bad. It's going to take some filing time. I did some preliminary measurements, and it is the same gauge all the way across, all the way around, so that's good. That gives me a flat clamping option this way, and I can side mill everything and do all of these dimensions basically at one shot, and then stand it up to drill it. Well, that's the plan. Let's grab a file, some patience, and a cup of coffee, and figure out how we're going to make this thing go away. I have a feeling it's going to be a corner round tool in the mill right there. That's an awful lot of meat to try to file off and make it look pretty. Give it a shot. The combination of a Sharpie marker or any type of marker and a file, I think, is a fantastic aid in visualizing what you're trying to accomplish. The Sharpie marker usually fills in the voids, and the file will just instantly show you where those voids are when you start cutting away the black. It works incredibly well. If you haven't tried it, give it a shot. Man, that is ugly. Woof. All right. Well, more filing. Not going to bore you with it. I'll bring it back and show you when I'm done. Actually, I'm going to put this back in the machine, and I'm going to mill off this inside. I'll show you that operation. But the rest of the filing, seen it once, seen it a dozen times, right? Just going to round these corners off, blast it. I'll be back. Well, the mismatch on this little piece is just a little too aggressive on the back side of this area right here. And now it's going to take forever and a day to knock that off of there. So I'm going to do it in the mill. I'm going to mill that out and just rotate the piece a bunch of times to knock this down and then file it in to match, of course. The arm itself, this little section right here, is just visually positioned parallel with the jaw. If you look through it from the back, I can't get the camera down there low enough to show you the gap, but it's just a very small parallel gap right there under the casting. All right, so let's put some marker on there and have at it. Since the nose of the part is wider than the body of the part, spacer blocks are required to rotate the part. Each one of these cuts, I'm trying to form a flat on this part that projects about the same distance into the radius on the far side. This is all visual right now, and the length of that cut is the determining factor. I could probably go deeper if I wanted a smaller radius on each side, but I'm going to try to keep the big radius on the thicker features so that it looks more authentic. All right, sometimes you got to know when to say when, and I think I'm saying it right now. Got some file work to do to knock the corner out, remove the facets, blend all the rounds, and make this top look round again as well. Kind of work that's good for a Saturday morning with a cup of coffee. Back to the bench, show you when it's done. After some bench work and some blasting, the parting lines are satisfactorily removed. The ones that will be machined off are still present. And on the print, the dimension between these two arms is about the diameter of this pin. Well, it is the diameter of this pin. So you can see that is relatively close to the inside of each one of those arms. That's about the only critical thing you're going to have to watch out for. You're going to end up with a notch on the inside of this. And the following dimension from there would be the inside of this to the top of this. And then the thickness. So if the thickness falls in to hit this arm right here, make sure you use an end mill that's large enough to keep that radius and possibly file and blend it out after the fact as well. I'm going to do this in a relatively unique, easy setup. I'm going to hold it this way on my fixture plate. I'm going to clamp it down up on a riser block. As I was forming this, as I was filing this, I maintained parallelism right there. So it's safe to clamp on a little riser plate this way. I will side mill all the gaps, and then I will just simply flip the plate up and I will drill the holes. So no messing around. It's going to be, the holes will be as perpendicular to the flat surfaces as the fixture is to the machine. Should not be a big deal. Give me a chance to set this up in the mill. This will be in the vise. I will use a 1-2-3 block against the back stationary jaw to establish the rotational positioning of this part. Then I will clamp it down. Then I'll mill it. Okay, that's how it's going to be. Let's do it. Before we start cutting, let's take a look at the setup. The part is up on risers. The part is square to the back jaw. 1-2-3 block was placed here while the plate was subsurfaced to the rear jaw. The plate is up against the stomp. I've put an edge finder against this surface right here. Knowing these diameters, I know now where the center of those journals is, so I can rotate the part straight up and not have to change anything. And finding all the dimensions should be relatively easy. Once I establish the inside dimension here, I will offset the cutter back the diameter of the cutter and then simply make the decimal move or the dimensional move to hit the back surface relatively easy. So once this surface is established, that'll be a 0 surface. Going to move the cutter 125, the diameter. That puts the edge of this surface on the edge of the cutter. And then when it shifts, it's a true shift. To establish this height, that would be relatively hard to check. So let the digital or the dial tell you where it's at. Now let's put a cutter in here, clean these things up, flip it, drill some holes. Prior to starting this cut, I put a very small gauge pin in my drill chuck and I danced this part back and forth on the y-axis until the pin made contact with the inside of the casting. I zeroed both sides, found the center line, and set my 0 there. I double checked the setup as I was cutting with a mirror because I just couldn't get my face or my eyes or anything else in there with the camera positioned where it was. And go to a bigger mirror if you have to. Do what you got to do to make sure it comes out the way you want it. The cutter position is currently sitting at the location that formed the inside finished surface right there. I know that the cutter diameter is 124, so I'm going to shift the cutter 124 that way and zero out the Y digital. Now we have this side of the cutter true to the inside of the part. The next feature to be cut is dimensioned from the inside of this opening right here to the back side of this opening, or this boss back here. And you can see how that would be a little bit difficult to actually measure. So by having the cutter aligned right here, it is a straight up table shift to the required dimension. And then when the cut is made, you can trust the digital to have delivered the feature you're looking for. With the digital currently sitting at the finished location for the outside step that I just did, I'm going to do exactly the same thing I did to get here. I'm going to zero out the Y-axis digital. I'm going to move the table, the thickness of the cutter, 124. And I'm going to zero it out once again. Now all I need to do is a true shift of the table to get to the thickness of the boss, and I'm there. If you can't get a measuring instrument in there, trusting your dials or digitals is the way to go. Let's do it. With all the milling complete and having taken the time to find the part and measure the part prior to making this setup, flipping to a vertical format to drill the holes should be relatively quick. I am quite pleased with the way this came out. All the casting marks, all the mismatches came out. I could have used a little bit bigger cutter in this corner right here. You can see if I matched that radius, that would be a little bit cleaner. But then again, I would probably have to blast it again, and that would mean I'd have to mask it again, and I didn't feel like doing that. So a gentle wipe with some Scotch-Brite on all the machined surfaces. Broke the edges with a file. The 125 bore that goes through there. This is a 125 center drill. The pulley that fits in here has the set screws in it to secure the pulley, so it'll trap the shaft that goes in there. The ends are not called out as machined on the print, but I cleaned them up because they were mismatched, and I think it looks a lot better this way. The casting defect on the end, well, there are some things you got to live with. I could probably file that out and fake that in. I may actually have to do that because that little nick right there is going to bother me for all eternity. Anyway, there you go. Get out of it what you put into it, right? Satisfaction guaranteed. I thank you very much for tuning in for these two parts. There was an awful lot of work in both of them. And as simple as it looks, never underestimate the simplicity of a part just because it looks simple. Take your time, do it right, do it once, move on. Thank you very much for watching. Wherever you are in the world, I hope you're well, happy, and safe, all of the above. I am Joe Pa here in Austin, Texas. Thank you very much. I'm out.